Hey. Sorry? Ritik went to get a piece of hardware.
Is there anything I can help with?
Everything's set up, so yeah.
You move this late for the organization plan. I even lost my glasses.
Oh,
I could look back up.
yeah.
Hmm? Hey everyone, we'll be starting in a minute or two, and if you don't mind, you can just turn this way. Like, it'll be easier for you to pay attention. How's everyone doing? All good? Prepared for? Did you guys come to the other workshop yesterday? That makes sense. I mean, I was there. Yeah. Are you guys planning to go to the other workshops throughout the week? Not bad. I think the next one's on 4th. Yeah. Building with NeurAlbertaTech. Do you guys have experience with hardware before this? Any kind? Somewhat? What do you work with? What about you? No? None of yourself? Oh, that's good. At least we have some beginners over here. Last year I had some tryhards just come in and they know everything about hardware. I'm like, okay. Everyone was a PhD or master's student. Yeah. That's nice. Yash, ETA? Uh, start it and let me know. Sure. Also, quick disclaimer, I'm playing this by mind. I have not prepared anything. So if you have any questions, if you feel I'm saying something wrong, let me know. And I'll answer your questions in between the session. Start. All right, everyone. Welcome to the second workshop of natHACKS 2024. It's called Hardware Zero because of zero indexing in computer science. So it starts from zero. This is where you learn what the hardware is, how it can be used. There won't be any practical knowledge in here, as in to make projects. That one's going to be in the second workshop, the following part known as Hardware Primer. It'll be during the hackathon, so people know what they're working with and they have access to the hardware in hand. I have a couple of pieces out there for the table on the back as well, so you guys can look around when I ask you to. So let's begin. I'm Ritik Kumar. I'm the co-president slash director of hardware for natHACKS 2024. I was a part of NAT for about 2.5 years now. 2 years, I believe. I started off as vice president, and just so all of you know, so that there's no hierarchy between us, I'm still an undergrad student. There's almost, I might know as much as you do, but a little bit more, and I'm here to guide you. So there doesn't have to be that I know everything and you guys don't, and you guys are a bit, you're not asking questions because of that hierarchy. So I'll share the slides after this. So if you guys need anything, let me know. Let's start with hardware. So the first hardware that we have is the OpenBCI. I believe, yeah. This is going to be another version. It's not Ganglion exactly. It's the Cyton Daisy. So the Cyton, they both are close. It's just that it's more developed. It has more features. Both of them have 16 channel signals. So this goes onto your headset, onto your head, and it has support electrodes and actual spiky electrodes that go onto your skull, the base of the skull, and then pick up signals from that. You can use this to monitor your hand movements, muscle movements, certain part of your brain. It could be the first quadrant, the second quadrant, the third or the fourth. I've used this before in building a prosthetic, which I'll come to after this. So right now we're going to discuss all of the hardware and then the applications of it. So though it might look different, the use case is almost similar. This is a bit more research grade, not much difference. This is something you'll have access to in the hackathon. It'll come with a deposit and you can just have it and then you can give the deposit back and we'll give you the hardware. It's fully refundable. Apart from that, this is on demand only. It's not that it's something given to everyone because it's expensive. Once you guys register, you'll have a form to fill out for the hardware. That's where you'll choose OpenBCI, and we'll go through all of the lists and decide who gets what, because there are limited versions of these. And yeah, this is an EEG headset. It can be used for EMG and ECG as well. And let's move on to the next one. I'll leave it on the table just in case you guys want to see it later. So yeah, this is the most famous one. This is kind of what our natHACKS is known for, because of the fact that it's so research grade and people don't really get access to it. It costs upwards of 1 to 2K, and people really can't have it in their houses. So they come to our hackathon, get access to it for a very cheap price, and get the money back after using it. All right, moving on to the next one is the BioAmp EXG pill. Could you take it from the table, the one with the cables? And you guys as well, I left one for you on the table. Oh, no, that one. It's a couple of cables on the side. Yeah, that one. That's the entire thing. So the BioAmp EXG pill, the reason there's an X on the EXG is because it can be used for EEG, ECG, EMG, and EOG. So it's like an all-rounder in place. This is a very beginner-friendly open source hardware that you can use to understand how EEG works, EOG works, and ECG works, etc. This works coupled with the Arduino Uno. That's the blue color board on your table. Now, we'll move on to Arduino after a bit, but this is what you'll be using it with. And this is something I started my journey in neuroscience with, because I did not know what and how things work in our body. This is the easiest couple of cables, couple of resistors, just so that you don't overpower it. And that's about it. You open the Arduino application on your PC, and you can see all the waves going here. You can see your heart rate. You can see how your muscles are moving. Let's go to the next one. This one. Let's do Arduino Uno. That's the blue color board in your hands over there. This is known as a microcontroller, but that's actually a wrong term used for it. You see the rectangular black board in it, that's the microcontroller, whereas Arduino itself is just a circuitry board that's based off of the microcontroller, that's the ATmeg. Now, this is the beginner-friendly hardware that everyone uses to get in the domain of hardware. I got into it as well. I tried building things like, when I say something, it's going to be connected to a mic, and it's going to detect my voice and turn off the light, turn on the light. It has two boards, two lines of pins. The top pins are known as digital pins, and the lower ones are analog in, and has power as well. Power has two main reasons, obviously, positive and negative. Negative are going to be, it'll be known on the board by G&D, the ground wires, and positive are 3.3 volts and 5 volts. And I believe I have a schematic of this. Yeah. So the analog input pins is basically, it monitors voltages from 0 to 5 volts, the variable volts. So it can be like 1.1, 1.2, 1.3, etc. Whereas the digital I/O input and output pins, they track mostly binary. So it's zeros and ones. So it's like turn on the light, turn off the light. That's about it. It takes in two values. But there's something called the third input, which will be a bit more complex if I go into it right now. But basically, this is what you'll use for if you need values out for something. Imagine a distance measuring device that you guys made. So distance are going to be variables from 1 to 2. It's going to be 1.1, 1.2. So you're going to be using the analog pins and the digital pins. So because you need the in and outs, as in if the device is on and off. The amazing part about this is this can be off your PC. It doesn't have to be connected to the PC all the time. That's where that DC BAL jack comes in. And the USB connector is what connects to your PC to program it. There's a software called Arduino, the main branding of it. You download that and you program it in C/Python, so Cython or C++, it depends. Very simple language, easier than Python, because you can literally look at it and just read what's going on. It's not going to be that difficult. So if you guys are a beginner, it's going to be all right. I'll give you a sample project. How you could use it is program an LED to turn on and off every 5 seconds. So in the code, there's going to be digital write and digital print, and then there's going to be a CL out, and then there's going to be a delay of 5 seconds. So delay of 5 seconds is what's going to be like, after 5 seconds, turn off my LED and turn it back on. Very simple, will require an Arduino, a little bit of programming of like 4-5 lines, and an LED. Obviously a power source as well. So this is your best friend to begin with. If you don't know any hardware and how to begin, like anything, you know how to use it, start over here, and you'll eventually make your way up. Let's come to the newest Arduino. Though the Duino stands over there, it's not exactly a part of Arduino. It is from the same family, I believe, because it's a circuitry board that has a microcontroller on top of it, and that's how you control the device. Now, this is a neurostimulation device. That means it literally shocks your muscles when you connect it to it to provide activity. And it can be used for motor rehabilitation. For example, when people have been in an accident, they can't really feel their arm and they can't connect, the mind to muscle connection is not there. So that's when a person tries to move their arm, they shock their muscles in very small increments so that they start to build the mind and muscle connection, and then they can have their motor abilities back. Again, this is also limited. We have only like 4 to 5 pieces of this. It's only going to be given to people who have a good project idea, and they'll be given preference. Otherwise, yes, you can obviously opt for this, and we'll see if we can provide it to you. Just a second. Let's go to the Raspberry Pi. Now, the main issue with projects are that you always need to have the computer connected to it. So why not just have a mini computer that can just be with your project? It can be standalone. You don't have to have wires connected to the project anymore. The Raspberry Pi is a mini computer slash a small piece of hardware that acts like your PC. This is where you don't need all of the computing power of your laptops because they're massive and they don't really need that much power. That's where this comes in. It has two variants. One is 8 GB and 4 GB. You can run machine learning models on this so that if you require a really you have an extensive model that requires a lot of running, you can obviously opt for the 8 GB model. And this is the 4 GB model I'm showing you. I think the one on the table is also 4 GB. I could be wrong. I'm not sure what I gave you. Yep. So this is something, I'll show you the schematics as well. Exactly a computer. Has USB ports, HDMI ports, power cable, audio, mic, camera, LCD screens. So when you opt for this hardware at a hackathon, it comes because it's a standalone and it needs an output device. That's going to be a screen. And as you might know, laptops don't take outputs. They don't take inputs. They only give outputs. That's where you'll be given with each Raspberry Pi will be coupled with a LCD screen, 7.5 inches, or I believe a little bit more than that, and it's a touchscreen LCD display. So this and the Raspberry Pi go hand in hand. So if you opt for a Raspberry Pi, you'll get an LCD screen. Everything that's for the power cable, HDMI cables, everything is going to be in the box. So it's all of those are going to be a small kit. Well, most of them in the back. It's all right. So yep, very useful thing. So once you've done building your project on the Arduino, you can connect the Arduino directly to this and let this be a standalone device as a whole. So yeah, one second, I didn't do the Muse. Let's go back to the Muse. This is the EEG device that everyone will use at least once to get familiarized with how OpenBCI works. Now, OpenBCI is something like really advanced. So you need to know how small channels, like this is coupled with 4 channels only. It has a sample rate of 250 megahertz, if I'm not wrong. And this is something that you use to get familiar with OpenBCI. The usage of this is, as you see the gold plating over here, the middle one is a reference channel. The left 2 and the right 2 are the 4 channels. The way it works is it detects potential differences between those 2 pads when it's on your forehead, like so. I'll give you a small demo of it towards the ending. And the reason this piece of hardware was made is because the brand Muse made for meditation to monitor people when they're sleeping, so they can help with that. Also, how your muscles are working. Just a minute. And how your muscles are reacting to things at night, and understanding how your body functions as a whole. Again, it's a meditation device, but what we do at natHACKS is literally hack things into things they're not supposed to be used for and make new projects. Yes.
So I would say like compared to the cost of used to and
Mhm.
one's more like a more viable option to
Given, right, so do you have any experience with these before? Do you have any experience with the Muse or the OpenBCI before?
I use that one.
Yeah.
Not that.
So this one's, I would say, rather invariable and not the most accurate, but this is something you would use to understand how things work. Because again, you can't go directly for the OpenBCI if you have no idea how things work. This is a cost price of, I believe, 200 to 300 if I'm not wrong. Don't quote me on that, around that. And you can buy it as a hobby project, keep it with yourself. Obviously, we have a lending program at NAT as well, apart from natHACKS. So beyond natHACKS, you can obviously lend all of these hardware from us for a small deposit. So I would say that's obviously more accurate. It has 16 channels compared to just 4 channels. Affordability, this comes first place because of, again, you can't really go wrong with $200. Yep. So brainwaves and mostly that's about it. Second one is exactly the same thing, but it does not come with the plastic. It comes with a band, so you can sleep with this on and track your sleep the sleep variability slash when you wake up, when you don't, the whole sleep activity throughout the night. This has been used for researches and trials to understand when a person sleeps, how what kind of dreams they're having, sleep apnea being one of them, how it's caused, what's causing it, etc. So again, this is a research grade project hardware. So feel free to use it. Amazing hardware. You can build a lot of things with this. I'll come to that in the project side of thing. The hackathon. The hackathon is a prosthetic that was worked in that around a year or two ago. I was a part of it. So we use the OpenBCI and cite on anything works, honestly, anything that's accurate. What we try to do is we have a machine learning model. We train the machine learning model using the OpenBCI that I'm opening and closing my hand, my fist. Now that machine learning model learns it and throws it out to the prosthetic hand on the left. So it kind of mimics what my right hand is doing. But the whole idea of this is when, for example, an amputee, he has no arm, but then a fact maybe some people might not know, even the body does not know that you don't have an arm when you're amputated. So the body keeps sending signals to those nerve endings, and that's what we connect the prosthetic to. And when the nerve endings are trying to send signals, that's where the open BCI captures it, sends it directly to the prosthetic, and now you can actually help someone with a disability to move your hand. This is one of the most famous projects. Another person who worked on it was Haisen Fa, a researcher, master student. Uh, yeah, that's one of the most famous projects that I worked with. Amazing project. Let's go on to the next one. The electrocardiography slash, again, it could be EOG, EMG, anything. This is built using the BioAmp, and it uses the blue board that you see is a Arduino Nano. It's just a smaller version of the Arduino Uno, but with less capabilities, but that's enough for it to run the BioAmp. Now, this is the most simple project that it's there on their website. All the links will be provided on the sheet, so on the slides over here or towards the end of it. So make sure you go through it just to have an idea what you'll be working with. You can obviously formalize your idea that you'll be working with in the hackathon, so you don't have to waste time on, okay, I'm going to decide now what I'm going to make. So yep, that's a good tip for you guys for the hackathon. Next is line folding robot. This is made using an Arduino, two infrared sensors, two servo motors, a chassis, and a shield. The Arduino has multiple pins. So for instead of you building external circuitry, it comes with a shield. And we won't give that out, but that's in the picture, so I'm just going to tell you what it is. It just goes on top of the Arduino so that you don't have to build a circuit of your own, but rather you can just connect things to it and it's just like plug and play. This basically looks for when the robot slash the project is on the black line, and as soon as the infrared senses that's going onto the white part, it tries to follow the black line again. So pretty simple. Again, this was perhaps my third or fourth project which I tried with the Arduino, and that's where I started my whole journey with Arduinos as a whole. So this is the layout of how things work. Arduino, the IR sensor on the left and right, and the servo motors go to the shield, but this is mainly how the IR sensors will work. Coming to the brain drone. Again, fantastic project that was made. So we used both OpenBCI and the Muse to build this. So the idea about this project was you control a drone purely with the headset. That's about it. There's no controller in your hand. Again, this is a controller technically, but you're not physically doing anything. So the way it was, the machine learning model and everything, the way it was made was you think of the color red or yellow based on the frequency of what your brain is emitting out, it picks it up and then goes left or right. So it's based on color. So red, go right, yellow, go left. Again, this is not accurate, but this is how it worked. You think of a color, you code that color to the direction you want it to move in, and then it works. You can also control the directions, takeoff, landing, literally by thinking of a color. This was made by a person who's no longer with NAT, named Cameron and Zach and a couple of other people. Amazing project, and this is I think one of the first project that NAT got famous because of, because again it was a small club and then it grew into an NPO. Before I go to the next one, any questions so far? Yeah.
How accurate is this one?
This one? Um, Based on the percentages, I could give you 75 to 80%. But then again, it has its own faults that it would keep going left. And the most of the drones are usually equipped with IR sensors. So whenever a person is controlling it and they go directly into a wall, it would protect itself. Because again, it's going too close to a wall, the IR sensor is going to get activated and be like, do not crash. But when you do something like this, we are overriding everything that exists in the drone by using only its propellers and its direction control, the flight control. That's about the flight control. I think it's called flight controller. That's about it. So again, it will crash into the wall if you just think of going left. So it worked. It was a good research project as to how we can control things just by thinking. So. Mm. The International Space Station Tracker. So I think I could not find like a very interesting project on the Raspberry Pi. Again, because it's a small computer, right? You can't build project purely off of a computer. Obviously you can, but then not something that relates hardware exactly. What this does is it has a small screen on top of it on the Raspberry Pi, which is the green one, and it locates where the International Space Center is. So the International Space Station is it's using an API, so it knows where the location is exactly. It just tracks that. It's very basic, but the only good part about this is it puts it on a globe. I don't have a video of it, but then it's a globe, and the red dot keeps moving because the globe keeps revolving. So it's like a project that was made by someone, not a NAT. This was an internet project. I just wanted to get something for you guys. So this is it. Apart from that, we will be giving out sensors, small sensors like distance sensors, gas sensors, IR sensors. There are like 38 of them. You can choose from all of them. When you ask for an Arduino or a Raspberry Pi, you have an option to select which sensor you want. But this can be done in person. That's basic. We have a lot of stock for that. Everyone can get one. It's that much. So feel free to ask for sensors and whatever project you have in mind. Um, we're going to have a hardware station, obviously, at the hackathon. So the hardware station is going to be helpful for you to ask that, do you have parts for this project? You can let me know, my associates, whoever working with me, that, okay, this is the kind of project I'm trying to make, and this is what I need. If you don't have it, I can help you out with an alternative that maybe you guys might not know. Perhaps we can change your project to something similar, but not exactly the same, so that it can equip with the project hardware that we have. The entire hardware list should be available on that portal. If you go under hardware and renting it out, it'll show you a very long list of what all we have. So you can probably use it. Take the entire list, put into ChatGPT, be like, build me a small project. That could help you out. Yeah. So for the OpenBCI Ganglion, this is what's being given out, not the site on Daisy. The documentation for it, Arduino Uno, Raspberry Pi, BioAmp, and ideas. Idea is going to be something you'll need, is the Instructables website. So this is something I used when I was in high school. This is my go-to for finding projects, because people make their own projects, upload it over here. It's like a hub where you can find multiple projects. For example, the send email alerts with Arduino. It's using a ESP32 board, which works with the cloud. It acts like an internet server for you. And honestly, search anything over here. It could, yeah, sky's your limit. You can literally search woodworking and there's something will come up. It's not limited to just hardware, but to any and everything, even crocheting, honestly. Just search it up, will come up. This is really good website that you could use. And let's talk about, remember the Arduino hardware I was talking about? Let's look into that. See, so Arduino.cc will take you to this website. This is where you can learn more about the Arduino Uno and the other types of Arduino. And for the software, the IDE is what you'll be installing. CLI is something new. It's not that developed. I would suggest don't use it just yet, because it's going to make your things complex, because you're going to be using the command line. And again, not everyone here I know is good with, I'm not good with command line directly. So IDE is beautiful. I'll show you an example of it. This is what it looks like. Couple of lines of code over here. You're going to select your board wherever you connect, and you have the compiling button, the upload. There's something called the seal plotter. I would open it, but it will not. Yeah. So seal plot is basically a graph opens up and makes a graph out of your voltage differences, how the things are working between your Arduino. Remember the analog pins I talked about that measures voltage between 0 to 5 volts? You can literally plot how things are working on this. The seal plot is what you'll be using with bioamp to show the EKG, the going up and down. Again, it's just voltage differences, nothing else. So you're going to be plotting it on the seal plotter. I can't open it because I don't have an active project over here. Seal monitor, same thing. Pops up like a terminal on the bottom and spits out values that you're looking at directly. Yeah, any other questions so far regarding the Arduino, the sensors or anything? Mostly what I just told you all about is the basics of hardware that you will need to know, what the hardware is called, at least if you're going to make a search on it, and what we have available. Let's do a small demo on the Muse 2. Right. That's how you wear it. It goes behind your ears and across your forehead. You'll see most of the lines are starting to calm down compared to in the beginning when it was really chaotic. It will calm down. It will calm down even more when I'm quiet. I'm not talking to you. My eyes are not active because it picks up my eye active as well. Over here, I'll try to move my eyebrows and it will pick it up. It's kind of hard for you guys to understand where my eyes are moving because again, I'm doing it and I can actively see what's moving. First two are going to be alpha, beta, and gamma 3, and the last one is going to be a reference, which is the middle one. Apart from that, it has an accelerometer, which is again just how your your axis of your forehead is. Amazing. Sorry, disconnected. Right. So if I were to move it up, and yep, there you go. So you can monitor as in my head tilted leftwards. Oh yeah, you can use this to make a posture correcting device. When you're kind of slouching forward, it will give you an idea that, okay, you're slouching beyond a certain axis, make it straight, and then you go back up. That's one of the ideas I worked with. And yeah, and then there's the PPG, basically heart rate, but again, not the most accurate. And I'm not wearing it, but let's see. There. It's not the most accurate. I don't suggest you guys use this, but these are the use case scenarios. The best part about, oh, this is demo.NeurAlbertaTech, so I forgot to tell you. I just want this is used for, this is inbuilt, that NAT built, but you can always download the Muse app, and there's a software called Petal. It's same as this, which you can record the data in. So imagine I'm recording this data currently. It's a 5-second clip, I believe. You get all of the raw data literally in an Excel sheet and CSV format. You can take this, put it into a machine learning model, put it into any kind of model that you have to run through these values. If my heart rate is above 100, let me know that I'm supposed to be resting. These are different waves. So imagine my second wave is above 800. I'm not focusing enough. So perhaps you can make like a Pomodoro timer with this. That is, when you're not focused, the timer is When you're not focused, the timer pauses, and when you're below certain level, the timer restarts. So that's one good project idea. Again, those are very beginner friendly, but again, if you want to use it to any extent, go ahead. Yeah, you have a question?
So, is it realistic that you like could have this on your head all day long?
Yes.
Would it be dangerous?
No, it's totally invasive, non-invasive, and the hardware that is this one. It's literally a band, soft band. The only thing plastic is the front part of it. You can wear it throughout the day, monitor your activities, monitor your mood swings throughout the day. People with ADHD slash other disorders, you can use it for that. It could be a medical device. It's not really a medical device, but yes, it's something that supports it. So you can add your ideas to it and make things out of it. Yeah. Any other interesting ideas that you might have? I could help you guys build a project slash give you ideas for natHACKS. Again, this is just a once in a lifetime opportunity of president helping you out for the project. uh, Apart from that, this workshop comes to an end. Thank you so much for being a part of it and showing up. Yeah. Also, you guys can go ahead and look at the Saturn Daisy if you want. And other pieces of hardware, I'll leave the Muse as well. If you guys want to demo the Muse, you can demo it with me. I can show you how to use it. That's about it, I think. Yeah. I'll be here for the next 20 minutes or so. I believe we finished our workshop quite early. Yep, 20 minutes. So if you guys have any questions, let me know and I'll be right here. Thank you so much.
How much was the Muse S?
250. Oh wait, Muse S, that's 450.
Oh, is it?
But then we give it out for 250 deposit.
Okay.
All of the deposits, let me show you that as well. Right.